Question 4. The fourth term in the binomial expansion of qx squared minus 3 over x, all raised to the power of 10, equals 414,720 x to the 11. Determine the value of q algebraically. All right, so this binomial expansion has a little bit of a twist because we do not know this inside coefficient of q, but we're going to work it out. So right off our formula sheet, we know the formula for any single term in a binomial, and it's term k plus 1 is equal to n, choose k, a to the power of n minus k, and b to the power of k. So that's wonderful. I think we can use that. There's a few things we should note. The first thing is this. It actually means there's n is 10. It also means there's 11 terms in the expansion. It's always one more than your value of n. The fourth term, all right, so we do know where we have information about term 4. So term 4 is 414,720 x to the 11. Tells us that, so it's kind of telling us the answer here. The other adjustment we got to make, right, is if we have term 4, the value of k is not 4. We want to get t4. So the value of k would be 3, one less than that. Because when we substitute in 3, 3 plus 1 is 4. Obviously, we know the value of a just looking at our exponent. The value of a is qx squared, and the value of b is negative 3 over x. So we'll substitute those in as we go as well. So I'm going to start off and just say t4 equals, now I'll use my 10, choose 3, and my a is qx squared. I always prefer to use brackets for this. To the power of n minus k. So I'm taking a shortcut. 10 minus 3 is 7. We could do that right away. And then negative 3 over x, all to the k. Well, k is 3. Now the important part here is if we're not done, we actually have an equation here that we're going to solve. We get 41,4,720 x to the 11. That's what we want to end up with. So let's see what we can figure out. The first thing is 10 choose 3. This is a calculator part, but I'm a math teacher, so I'll do this first part without a calculator. And the first part that I'm going to do without a calculator is right here. So 10 choose 3. That's 10 factorial all over 10 n minus r. So right from your formula sheet, that's 7 factorial, 3 factorial. And if we keep using our rules, right, you actually kind of apply the exponent to both expressions, which people forget, but it's q to the 7, x squared to the 7. And then right here, it's minus 3. So minus 3 cubed, x cubed. So if we keep going here, when you're expanding these kind of expressions, expand the largest. 10 factorial, of course, is 10 times 9 times 8 times 7. But we can stop here because we'll get some cancellation. If you're stopping, be sure to put a factorial. We got a 7 factorial on the bottom. And 3, I'll just go 3 times 2 times 1. So right away we see 7 factorials go away. And q to the 7 is still q to the 7. 2 times 7 is 14, so that's x to the 14. Negative 3 cubed is negative 27. Negative 3 times negative 3 times negative 3. And x cubed is x cubed. So we still got this whole side over here, 414,720 x to the 11. All right, so let's get started here. We are going to have to use our calculator sooner or later, but I thought we could at least show you this expansion. So 7 factorials are gone. The 3 is going to change this 9 to a 3. And the 2 is going to change that to a 4, right? 8 divided by 2 is 4. So that's 120. 3 times 4 is 12. 12 times 10 is 120. Now, when you're doing all this, just put your numbers in front. So 120 is my number for the front. But what are some other numbers? I have a negative 27. Keep brackets around it so you don't get that confused with subtraction. My other number actually is q to the 7, which I guess I got to find q. And keep your exponents together. So this is x to the 14 over x to the 3. And that equals 414720 x11. So we're getting there, I think. I'm going to use my calculator. I apologize to people who could do this in their head. You're much smarter than me. I won't bother to type in a negative. I know a negative times a positive is a negative. So this is negative 3240. Whoops, negative 3240. I hope that's clear enough for you. Q to the 7. Here you subtract exponents. I'll do that in my head. 14 minus 3 is 11. X to the 11. Now that shouldn't be a great deal of surprise, because when we look at the other side, we get x to the 11 on the other side. So the fact that we got x to the 11 on both sides is kind of indicating to us that we're doing this question correct. Right now we can just cancel that off, and now we have an equation that we're going to solve for q. So in order to isolate the variable q here, we are definitely going to want to divide both sides by negative 3240. We divide this by negative 3240, and that cancels there, and it will give me back, of course, q to the 7. And got to use my calculator again. Right, so this is 414720 divided by 3240. Remembering it's negative. So negative 128. So I got a negative 128. And so now we want to take, right, the opposite of squaring is square rooting. The opposite of 7th root is, to the power of 7 is 7th root. So we'll take the 7th root of negative 128. And I'll show you how to do that on a TI. And, if you know 728 is 2 to the 7, more power to you. Okay, but 7th root, I got to go 7. I got to go math, and then it's the variable one, so number 5. And then negative 128. And then I should get negative 2, which is wonderful. So Q equals negative 2. Now, this question has been so long, I forgot what Q even means. So let's go up and see. All the way up here. Oh, okay, so it's just really Q. Yeah, Q can be negative because it's just the coefficient on the x squared. So determine Q algebraically. We did all that. It took a while, but Q is negative 2.